Okay, today we are starting chapter 6. Today is section 1, and we're going to learn how to use similar polygons. Now, at the beginning of the chapter, we're going to be talking about polygons in general. As we progress into the chapter, we're going to get more specific, and we're going to learn shortcuts for proving triangles similar. So just like we had the shortcuts for proving triangles congruent, we have shortcuts for proving triangles similar. But for right now, it's just polygons in general. And when we want to show that two polygons are similar, we need to show that all of the corresponding angles are congruent and all of the corresponding sides are proportional. Now, when I'm referring to similar polygons, really what I'm talking about are two figures that have the same shape. We just have a little one and then we have a bigger one. Or they might start out with a bigger one and then it's a smaller one. But they will maintain the same shape because all angles are going to be congruent. So in this figure, I could label, and again, over here in this box, this is my similarity statement. The symbol for similarity is this wave-looking thing. Looks like a wave. So that is the symbol for similar. And I know I'm getting ahead of myself here, but when I'm asking you to give me a scale factor, the order of the letters in the similarity statement are going to be important. Now, again, just like with the congruent statement, we can match each letter with the same letter or the other letter that's in the same spot. Okay, so again, similar figures, that little yellow wave looking thing is the figure indicating similar. And again, each angle, and again, we can match them, A with M, and I'm going to put this same kind of mark on angle A as angle M. Then the second letter, angle B with angle N, that is congruent. And then C with O. And then lastly, D with P. In order for figures to be similar, the angles must be congruent. Also, the sides must be proportional. Now, these sides here do not have numbers. I'm going to go ahead and add in numbers, and we need to make sure that when we match up the sides based on that similarity statement, that they will all simplify to the same ratio. So if I add in a 6, an 8, an 8, and a 10, and then put 3, 4, 4, and 5. Now, over here, this is my statement of proportionality. It's showing that side AB, which is the first two letters of my similarity statement, match with the first two letters of the second, so from the MNOP. And then BC with NO, CD with OP, and AD with NP. I'm sorry? Exactly. And that is going to become our scale factor. But you need to check that all four sides simplify to the same ratio. So if I take side AB over MN, AB is 6 over 3, 2 to 1. Then if I do the next one, BC over NO, and that's going to give me 8 over 4, which again is 2 to 1. And then if I do CD to OP, CD is 10, OP is 5. And lastly, AD to MP, and that's 8 to 4, or 2 to 1. The scale factor, and that's going to be on the next slide, is what each one of these corresponding side lengths simplify to, the ratio. So the scale factor here is going to be 2 to 1. Now, notice the order of the letters, how they gave it to me as A, B, C, D to M, N, O, P. That's why I need to write it as 2 to 1. If I would have reversed it and said, give me the scale factor from N, N, M, N, O, P to A, B, C, D, then it would be 1 to 2. remember there are three ways to write a ratio. You can either write it with the word TO, you can write it with a colon, or you could write it as a fraction. Those are the three ways to write a ratio.
If we wrote it,
You're asked to give the statement of proportionality, you need to write it as fractions and show the sides that match. Because what we're going to be doing here is solving proportions. So what you're going to need to do is write your scale factor as a fraction, because that's how we're going to be finding the missing sides. All right. So now the next slide talks about the scale factor. So if two polygons are similar, the ratio of the corresponding sides of two similar polygons, that ratio becomes the scale factor. And again, the order that they're asking you to list the scale factor, it's based on the letters. And again, the scale factor is going to be the simplified ratio. Always simplify it. Okay, so we're going to be paying attention to the orders of the letters that they're asking us. So if I ask you to give me the scale factor from ABC to DEF, you're going to take one of the sides of ABC, which is 3, and then one of the sides, because this is equilateral, equiangular, and my scale factor would be 1/2, or 1 to 2. Now, if I change the letters up, and I said from DEF to ABC, then you need to write it as 2 to 1. Okay, but again, we're going to be working with these as fractions. So pay attention to the order of the letters and always reduce the ratio. Okay, so the next slide has some quadrilaterals here. It wants us to find the scale factor of ABCD to MNOP. So what I need to do is I need to find the two sides that have a complete ratio, not one of the parts of the ratio as a variable. So if I start going through, so if I first look at AB, the first two letters with MN, notice I don't have a complete ratio. I have 12 over Y. Then if I go to the next two letters, say BC to NO, BC is 4, NO is X, I still don't have a complete ratio. And then if I go CD with OP, the last two, I still don't have a complete ratio. But if I use AD with MP, I finally have a complete ratio, and it's 10 to 8, and I need to simplify that to 5 to 4. So that would be my scale factor, and again, the order is important. It's 5 to 4. Now, to find the values or the lengths of X, Y, and Z, I'm going to set up a proportion. I'm going to use what I wrote at the bottom along with my scale factor. So let me go ahead and set up my proportions. I'm now going to put equals 5 over 4. And now I'm going to cross multiply and divide. I'm solving a proportion here. I'm doing cross products. Now, generally, I've been allowing you to leave things improper, but because we're looking for side lengths here, I want you to make these either a mixed number or a decimal. If it's a repeating decimal, leave it a mixed number. So let's try these. So I'm going to cross multiply here. 5 times y, so I'm doing cross products here. 5 times y, 4 times 12, divide by 5, and y equals 9 3/5. The next one, yes.
So on a quiz, you would have to leave it as either a decimal or a mixed number.
Correct. Okay, the next one, again, cross products here. 5 times x, 4 times 4, divide by 5. 5 goes into 16 3 times with 1 left over. And the last one, 5 times z, 14 times 4. Divide by 5. And 5 goes into 56 11 times with 1 left over. So these are the answers to part B, the values of each of these side lengths, x, y, and z. The next step, step C, says to find the perimeter of each of the polygons. Remember, to find perimeter, we add up all the sides. So I'm going to go over to the larger quadrilateral here, and I'm going to add 10 plus 12 plus 4 plus 14. This will give me 40. Notice there are no units here. They don't tell me if these are inches or centimeters or meters. So I'm just going to list it as 40 units. Then for the smaller one, I'm going to add 8. I'm going to add 9 3/5, 3 1/5, and 11 1/5. Now notice these 3 fractions. When I add these, this becomes one whole. So then all I have to do is add 8 plus 9 plus 3 plus 11. I get 31 plus that one whole. So the perimeter of that one is 32. And again, units.
Wait, so you just add the y's and the x's and the z's together?
Yes. Uh-huh. And the 8 that was already there. Right here. So I added all of these up. Okay, then the next part, part D, says to find the ratio of the perimeters. So the perimeter of my larger quadrilateral there is 40. The smaller one is 32. This will simplify to 5 to 4. On the next slide, we're actually going to learn a theorem that is just going to explain what we just did. That the ratio of the perimeters is the same as the ratio of the scale factors. Again, remember, when we're talking similar figures or similar polygons, they're going to have exactly the same shape. The size is what changes. You'll have a smaller one and a larger one. The next is the theorem of what we just did. Again, Theorem 6.1 doesn't mean anything to us. It does have a name. So if you ever had to use this as a reason and a proof, you would say perimeters of similar polygons. And it states that if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So what we just did on the previous slide, showing that the ratio of the perimeters simplifies to the same ratio as the corresponding sides or the side length. So they're going to reduce to the same thing. So this is also saying the same thing. So this one says that the corresponding lengths in similar polygons, if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is always going to be equal to the scale factor. So in order for two figures to be similar, you need to make sure that you check all the sides and make sure they simplify to the same ratio. If they do not, then the figures are not similar. So notice in this example, they're giving me a similarity statement. They're telling me that these two triangles, this blue one over here, is similar to this red one over here. So if you're ever asked to find missing side lengths, you can find the scale factor and then set up a proportion. So notice I could take side TR and match it with XZ. TR is 6 plus 6, and that's going to be 12. And I would match that with XZ, which is 16. And then I can simplify that to 3 to 4. Now that's going to give me my scale factor. So now to find the length of PS, which is what they're asking me to do, PS is over here. Notice it's going to match. So PS is going to match with PY. So I'm going to take my scale factor, set up a proportion, and then I'm going to put X over 20. Again, I'm going to use cross products here. Now, sometimes the proportions are nice and pretty like this, and you can just look at this and figure out that, hey, I noticed I multiplied 4 by 5. I could do that to the 3 and get 15 here for X. However, if you don't realize that, then you're going to do the cross products, 4 times X, 3 times 20, divide by 4, and X equals 15. And that would be our missing side length. Now, let's say they wanted another missing side. So let's say they gave me the length of PR, which are these last 2 letters. Let's say I told you this was a 15, and I wanted you to find PZ. So then what you could do here, again, take your same scale factor, and again, put 15 over Y, because this is 15 is coming from the smaller triangle. That's why it goes in the top. And then 3Y equals 60, divide by 3, and Y would equal 20. I just picked a random number for 15 just to show you that you could use the same scale factor to find a missing side of the red triangle. Okay, so that's it for 6-1. Again, these are similar figures. One will be small, one will be larger, same exact shape, angles will be congruent, sides will be proportional. So you do have a homework assignment, and you can get started on it now.